Okay, good afternoon, everyone. Can you hear me? Is everything okay? Earth to folks? Okay. All right. So, welcome to our talks. Appreciate you stopping by, getting the shade for a little bit this afternoon. And so, as astronomers, no matter where we are, we're always looking at the night sky. We're always trying to figure out, like, what's up there? What is it? And I love this little chart. It's kind of a cute little cartoon. You know, is it twinkling? Is it moving? Is it blinking? Is it a masthead? Is it a boat? Or is it a fireball? So I got that. So again, I'm Roxanne Kamin. I'm out of the Harrisburg, Hershey area, part of the Astronomical Society of Harrisburg. We put on the Cherry Springs Star Party up at Cherry Springs. So if you have any questions about that, let me know. Also with the International Occultation Association and also the Rhine Observatory down in Muddy Run. Is the volume okay, or do I need to turn that down or anything? Good? Okay, great. So today we're going to talk about getting published. Everybody enjoys using your telescope, but after a while, let's say, what else can I do with my telescope? What else can I do with this expensive toy? Okay, so let's talk about different ways of using your data and your images to contribute to the science of astronomy. Okay, starting out at kind of a very, very basic level, we wanted to talk about getting families and students involved in astronomy this weekend. SETI has a fantastic program that encompasses families, students of all different grades and such. So if you know anybody who's an educator, anybody, Girl Scouts, Cub Scouts, have them reach out to the SETI webpage. They've got family projects, they've got citizen science projects, and it's a really good resource to get the younger people involved into astronomy. All those people with the smart telescopes, man, they're popping up left and right. I was at a star party a couple weeks ago, and I swore there were 50 of them out there in the field, little sea stars, pretty popular items. And Unistellar has an excellent program. They're working with SETI, great programs for tracking asteroids, exoplanets, supernova. Again, if you have one of these smart telescopes, check to see what those telescopes are doing, what's available. Seastar is working with the Hoya project. They're looking for starburst in globular clusters. So no matter what type of telescope you have, you don't have to have one of these big, huge 100 millimeter, 100 inches and 1.58 inch telescopes to do, science. You can do science with the telescope that you have. Okay. Next, talking about you get the students we're working up. There are a lot of careers and internships. Usually I use this slide as one of my last ones, but then by the time the teenagers are bored, they're walking out of here, so I put this in a little earlier. There are just a plethora of internships out there. NASA, APL, JPL, Blue Origin, okay, SpaceX. There's a lot of them. People think, oh man, I'm going to go into astronomy. I got to think of NASA. Well, NASA is just one cog in the whole wheel. Okay, so think beyond NASA. If you're a student and you're interested in any of these, see me afterwards and I can send these to you. But there are a lot of different internships and careers that are appealing to students. Here are some specific ones regarding internships. Remember, astronomy nowadays isn't just going to the moon. Nowadays, they're looking for people who are botanists, because we're going to be growing plants on Mars. We're going to be taking plants up in spaceships. We need geologists. We are going up to asteroids. We're grabbing a bite out of that asteroid, bringing it home. We need to analyze it. We got to figure it out what it was. We used to talk to our spacecraft using radio waves. Now we use lasers. That next generation coming up. So again, don't always just think, oh man, I got to build rockets. I got to work for NASA. There's a whole whole world of things out there for anybody, any type of skill to be interested in. Undergraduate, graduate students, the L-Space program, Southwest Research Institute, NASA, Kentex Aerospace. Reach out to these companies. They're looking for you to do your undergraduate studies with them, and there's opportunities out there. Again, sometimes it's like with astronomy, you go out there at night and you set up your telescope and you're like, ooh, God, where do I start? There's stars everywhere. Where do I start? But just pick one. Just pick a constellation. Cassiopeia. Look what you can find in Cassiopeia. Look what you can find in Orion, and just start somewhere. And it's the same thing with these jobs and careers in the space industry and astronomy, because once you start pulling that thread, you'll find out that, oh wow, SpaceX isn't doing anything right now, but Blue Origins is, and oh, by the way, down the road from them is somebody else, and then you'll start networking and finding opportunities. Okay, Brian's favorite topic here. Everyday citizen science. There are a lot of opportunities out there. Again, just kind of finding out what they are. AAVSO is an excellent starting point for you. As you can see, they've got a ton of programs out there for you. I mean, they've got solar, exoplanets, gamma ray bursts. Can I catch a gamma ray burst with my telescope? Let's try it. Let's see it. Spectroscopy, variables. So it's just not variable star. AAVSO has a lot of different programs that you can tap into. And kind of the fun thing with astronomy is if you start doing something and you don't like it, you can change. You can use your telescope for multiple sciences. So again, just keeping on with AAVSO, they have excellent education. Their online classes, I'm always tapping into just to learn for myself. So they are a very supportive team, good group, good education. If you don't know how to do anything, try the AAVSO with their education programs, because they are very strong. And since Brian talked about them, I'm not going to go into them too much deeper. And good on NASA. At this point in time, I don't know what's going to happen tomorrow, but they have just a large selection of citizen projects out on the NASA website. You can do it. If I can get into this and I don't have a PhD, I barely got out of high school. I never went above high school algebra. Some of this stuff is like right over my head, but I'm still into it and I still enjoy doing it. So there are some simple things like Galaxy Zoo and such you can get interested in. They got 34 open projects. They're open to everyone. You can get on their white papers. Over 500 volunteers have been published on NASA white papers. Can you imagine? Think of that. It's like, man, I'm published on a NASA paper. I don't have a PhD. It's cool stuff. And extra asteroids, cloud sourcing. Many projects out there are cloud sourcing. If you're into data, if you love to mine data, you're Python, you're a coder, techo person into technical data, they want you, okay? Because these big, huge telescopes, the Webb, the Hubble, the Rubens, they are pushing so much data down the pipe that professionals can't keep up with it. They can't. And that data is yours. It's available for the public. I offhand can't remember the name from yesterday. Mars? But you can go to these websites and you can pull the data. Write your own code. Figure it out. Some of this is really a lot of fun to do. Okay? We're going to T-Cora. We're going to hear a lot about that lately. I'm not going to delve too much into it. But everybody's watching that star to see when it explodes. Okay, generally in magnitude 10, it's going to be a variable. Find it on Stellarium Star Atlas. We all know about it. But what I want to tell you is, if you're out there imaging Swing your camera over there, take 1,000 images, just run a list of it and keep it. But keep your raw data, okay? Because it depends on who wants the data is how they're going to want that data, okay? I'm pretty positive one of my friends caught a nova in, I think it was 101 or 107 a couple years ago. But he processed it, he stacked it, he did all kinds of things to it, and they couldn't touch it because he manipulated the raw data. So when you start working with these groups, they will kind of tell you what they want. If they want dark supplied, if they want flat supplied. Quite often they want the raw data, okay? So they can downstream process it using their tools and their techniques. So again, if you're out there and you're shooting T-Corona and you get a bunch of shots of it and it goes nova tomorrow, awesome, because you got that build up before it happened. But keep your raw data. Comet IO group. If you're into comets, this is the fun group to get on their mailing list. You learn about new comets coming around, what's happening with them. Here, this gentleman, 50 millimeter refractor, okay? Not a big scope, not a lot of aperture, but he took the data, he got images, he's got one of the first images of that comet. So you can do this, you can do citizen science. Doesn't matter if you have a C star, doesn't matter if you've got, the 24-inch obsession. All scopes in between, there is a niche for you somewhere. Okay, this part is where near and dear to my heart, the occultation type of work. It's like, how do you know something's like way out beyond Neptune? It's called the TNO, Trans-Neptunian Object. How do you know it's there if I can't see it? This thing's 22 meg. I can't see it in my scope. No way. But just like Kelvin and Hobbes here, where Kelvin blocks the light from his mom so she can't read the newspaper because his shadow's falling on it. Or just how when we did the solar eclipse, we watched the shadow go across the US. It's because when an object passes in front of a star, an asteroid passes in front of a star, it creates a shadow. And we capture the image of that shadow. So let's see if this works. All right. So this is an actual occultation. There's my target star. I'm watching it. Boom, gone. Cool, I caught it. And it comes back, promise, there it goes, it comes back. But you notice this is just a few second, this is just a few second event. I'm not imaging. I'm not doing 5-minute subs. I'm not doing, 5 hours of data collecting. I'm not doing 50 hours across 5 nights of data collecting. I got to get on this star, on this target, be ready to go, because I only have 10 seconds to catch this. Okay? And that's part of the challenge of doing occultations. You got to know your equipment. You got to be ready to go. And the fun thing about occultations, sometimes, this may take a minute to get, and sometimes they may surprise you. Because you'll be watching it. Oh, sorry, this is my data. So what we do with the occultations, I don't want to be in your way, is we study the light dip, the light curve. Boom. Light goes out. The light curve drops. Light comes back and such. Now you notice we've got kind of 90-degree drops. Asteroids are hard-edged. As far as we know, we don't have any with atmospheres at this time, but they're hard-edged. So our data drop is a hard data drop. Okay. So here's a light curve out of Steve down in Maryland here. Sometimes these light curves will surprise you because as you're watching the light curve, you get a second dip. It's like, oh, cool. Steve discovered a moon of an asteroid. So asteroids are not only solitary, sometimes they travel in two. Sometimes they're just, binaries traveling together. Sometimes they're binaries spinning around each other. Sometimes they have moons, they have moonlets. The asteroids are kind of cool. And we figure this all out from this light curve data. Okay? And if we get enough people together by seeing where that dip is in the light and where that light drops off, we can tell you the size and shape of the asteroid. Pretty cool, eh? And you're not talking about real big asteroids. These guys are kind of small. When you get a few more of us, we can tell you the rotational period of the asteroid. All from that information, just watching that light drop, catching that light curve, and then adding it to our groups of light. We can tell you the size and shape. After a while, we can figure it out. We can tell you the rotation and the axis of that asteroid. Now, this is your data. Okay, this is the data that you collect, you use, and we'll go into analyzing it in a little bit here. People say, well, why do you do this? Like, who really cares? Well, actually, y'all remember New Horizons? New Horizons went past Pluto, that beautiful picture we got from there. Okay, I've been fortunate to measure the atmosphere of Pluto twice, both the times through occultations. So we have the first time when New Horizons passed Pluto, we got that data, that benchmark data right there. And then we had another occultation of it where Pluto passed in front of a star. We got that data there, and it passed in front of a star again. We got another set of data. So we have 3 sets of data, which we'll look at in a moment, about the atmosphere of Pluto. Remember, a couple years ago, we had the DART project where we redirected an asteroid by blowing up its moon. Remember that? We shot a little rocket up, we hit the moon of an asteroid, and it blew up, and it shifted the asteroid out of its orbit a little bit. Okay, people who do occultations, we're the ones who help the group figure out the trajectory. We're kind of a ground-based test of the trajectory and motion of that asteroid. So they know that they're sending that space probe to the right place. And the last one, Lucy mission, study of the Trojan asteroids around Jupiter, near and dear to my heart. Fortunately, I've been able to work with that program quite a bit. The space probe is on its way to Jupiter right now to study the Trojan asteroids. So cool. Here we get into some spectroscopy, which is a hard word for me to say. But since Pluto has an atmosphere, and when Pluto passes in front of a star, it's going to gravitational curve that light from the star and point it to the Earth. So here the light's coming through. It's going through the atmosphere of Pluto. It's converging that light like a big old magnifying glass. Think of it that way. And it's pointing that light to Earth, and then we're going back through the atmosphere. So people who have PhDs and way smarter than I am can take a look at that light curve, the light waves, break it up and tell us what's the composition, what's the temperature, everything about the Pluto's atmosphere. And again, I'm just doing this with a little telescope. So this was a fun project. In fact, it's how I got into doing occultations. Somebody sent out an email to all of our local astronomy groups and said, hey, I'm doing a project with Pluto. Can I have a volunteer? I need some volunteers. I volunteered. And it's what got me rolling on this. We went down to Liberty University down in Lynchburg, Virginia. If you ever get a chance to go to their observatory, it's a beautiful observatory, custom-made 24-inch DFM telescope, one of the most beautiful scopes I've ever seen. Their observatory has parquet floors. And I'm up there and I'm going, guys, what do you do if it gets wet? What do you do with this floor when it gets wet in here? And they're like, gets wet? So obviously they don't use it in inclement weather, or they keep it well protected. My second project with Pluto, they sent me down to Catherine, Australia. And here, I'm not a PhD candidate. I'm not aligned with any university. I had a full-time job. And they're like, wow, you know, you did the work up at Lynchburg. Do you think you can come down to Catherine and help us out here? So I joined Southwest Research Institute for a trip down to Australia for a week, measuring the atmosphere of Pluto in the outback of Australia. It was a pretty cool trip. DART, I was talking a little bit earlier about sending the probe up to hit the moon of an asteroid. 19 members of our team in IOTA helped contribute data to make sure that that probe was on the right path. And here the person, he got an actual picture of the impact. Took it with a 12-inch SET. Okay, so work can be done with, you know, local observatories or your personal scopes. Again, keep your raw data. Okay, because it depends on who you work with, they'll tell you what they want. But if you always have the raw data, it's a good place to start. So that's kind of cool. You think about it, we sent the probe up and we hit the moon of an asteroid. You know, that's kind of cool. All right. This was a fun project, worked over in Harrisburg, Pennsylvania. This is our local university, little 14-inch Meade scope. And there was an article in New York Times about 2 years ago. They talked about finding a ring around an asteroid. There's only 4 asteroids that have rings around them. There's only 1 asteroid that has 2. And as part of the team where we discovered the second ring around this asteroid. Again, we were just doing an occultation, you know, we were watching that little screen and it dipped, the light went out, and then it did a double dip on us. We're like, whoa, we caught something strange. And that was really a lot of fun. That was in support of the European Space Organization. When you start doing these type of projects, and I'll show you where to find them, they will tell you what they want to collect. Do they want the raw data? Do they want the processed data? Oh, by the way, you're running a 14-inch scope. Could you run it at this cadence for us? Okay, sometimes they will help you with the setups because you got to remember that they want to sub-process the data. So you want to be able to present your data to them in a format they can use. I know people who dearly, dearly love their old video cams. The Wattec camera takes great sensitivity, awesome. It's a great camera for doing a lot of exoplanet occultation work, but AVI files, they have a hard time downstreaming them in today's software and today's programs. FITS is what they're using. That FITS is basically pretty much the file type of choice. Okay, launched back in 2021, the Lucy mission, again, near and dear to my heart. We were going to go look at 8 asteroids. Well, from 8 asteroids, we're up to 11 because we've discovered 4 moons, which is really kind of cool. We found a binary, we found some moons. Lucy right now is in that kind of the lullaby stage. We're kind of waiting for it to get closer to Jupiter and when it's going to start looking at these asteroids, the Trojan asteroids. Jupiter, like a big ship, has got a bow wake kind of in front of it and behind it. And these asteroids are gathering in front of Jupiter and behind Jupiter, the Roman asteroids and the Trojan asteroids. And we're studying them to try to figure out where do they come from? Why are they getting stuck there? It's a great program. I've been very fortunate to, once I got hooked up with the Southwest Research Institute, I worked with the Pluto project, both in Lynchburg, Virginia, Catherine, Australia. Then they sent me over to Tucson, Arizona, Orvis. We were down in Australia again, down in Darwin, Australia, which is fun. But there you also see Penn State's Wilkes-Barre. Okay, Wilkes-Barre happened to be in the path of this shadow of another asteroid that we're measuring. And what I do is I'll cold call the college. Say, hey, we got this going on. Can we use your telescope? You know, we're going to measure this and such. And we try to get these local colleges involved. As you can see farther down, we worked at Cornell up in Ithaca, Cherry Springs, Pennsylvania, Marshall, North Carolina. So all these are not, oh, we got a visitor. It's not like we always have to go to someplace dark, you know, like Australia or, you know, the backwoods of, you know, New Mexico or such. We are catching a lot of these here on the East Coast. This trip here from Adelaide to Perth, Australia, was a fantastic trip, a once-in-a-lifetime trip. 12 of us met in Sydney, Australia. Then we broke up into 2 groups of 6, went to Adelaide, picked up the telescopes in Adelaide, and then we drove all the way across Australia from Adelaide to Perth, doing astronomy every single night. It was awesome. Just, there's parts of Australia I will never ever see again. The people were wonderful. Like, we would stop in the evening, and they're like, oh, you're the group from NASA. Hey, Las, you know, and they were just the wonderful people. We were very well received, and it was a great project to work on. Justita back in September 2023 was kind of fun. It was in Wyoming, believe it or not, and that was with the United Arab Emirates. They got a space program going on, Justita. They're going to land on an asteroid. They needed to confirm the trajectories for asteroids. That's what we did. Got called up, say, hey, Rox, what you doing? We need you on Saturday. Can you go? And I'm like, yeah, I can. I think so. That was good. Euphrates up in Cornell. That was a fun trip, too, because sometimes you never know what you're going to get yourself into. And believe me, I got the call, can you head up to Cornell? We need you tomorrow night. And I'm like, okay, what kind of telescope am I working at? And they're, it's a 24 SET. So I'm thinking, oh, cool, I'm going to have like a scope like back ahead in Lynchburg, beautiful custom DFM. Now I get up to Cornell, and it's a hand-built 1968 magnesium. To me, it looked like I was looking at the Brooklyn Bridge. It was just, it ran PC Pascal. Anybody remember that? Okay, serious. I'm serious. We had the little computer there with the orange screen, and we were running it. Yeah, but I tell you what, that was one of the most beautiful, smoothest moving scopes I've ever worked on. True, it was frozen. We had to put hand warmers on to thaw out the RA clutch on it. But once it got going, man, it was one of the most beautiful, smoothest scopes I've ever used. And then Patroclus, I know it's New Mexico, Texas. Sometimes you end up chasing the clouds or trying to get away from the clouds. We went from Colorado to Lynchburg, Texas, to some other places in Texas, to New Mexico, Roswell, Texas, ended up back, I don't know, but I think I put like 2,000 miles on in about 4 days. So just be aware, if you do volunteer for things like that, you are just, you're part of it for whatever that duration of time is. But it's fun. It's an adventure. It can be scary. Sometimes it's a solo, lonely job. You're out doing occultations. It's kind of hard to get your boyfriend, girlfriend, spouse, significant other out there with you. Being out in the back of Australia, out back by yourself with the snakes and the scorpions and everything that's trying to kill you out there, was an adventure. It really quite was. So, okay, bring this back here. So, okay, so cool. I've gone out there. I've collected some data. This is for Hyakea, which is the moon of Haumea, a trans-Newtonian object. And this is kind of an interesting slide because when we look at our data, okay, if you're an imager, a lot of you use guide scopes, right? You use guide scope, you're guiding on that little star that's keeping your mount moving and such, okay? We do not guide because we can't have the mount arbitrarily, the guide PhD to tell it to move or shift while we're in the process of an occultation. So we don't guide. We'll track because we know the mounts, but we don't guide. So when we do our data, we guide within the data. So the top line there is our guide star. That's our star within the data that we guide, okay? And then we've got a comparison star. That star's light curve. And that's our comparison star. Think of it as adaptive optics. Adaptive optics live within your data. So a cloud comes through that dips and changes. We know to subtract that or add that from our data to make our star. And then here we had the actual event when Haikea passed in front of a star, created its dip in the light curve, and we got captured this. This was for the European Research Council, a part of the LISA project over in Paris. We actually were just recently accepted to the Nature magazine for our paper on that. So we're very excited, very, very excited to get that. Thank you. Just like I said, I barely got out of high school, okay? That's just the way I was, okay? I didn't take anything above, high school algebra. I've authored one paper. I've co-authored 4. I got 1 co-authorship with Nature. So trust me, if I could do it, you guys can do it. Just find your niche. It's out there, believe me. Once you find it, you'll enjoy it. So we try to get students in East Coast observatories to help us out in interest in occultations. As you can see, we got a bunch of them here. Oh wow, it's hard to read, sorry about that. But you can kind of see the locations. And if we do have an occultation that, I need a bigger telescope, I'll call Penn State. I'll reach out to Cornell. I'll reach out to a local group that I know has got a big Dob sitting on a hill somewhere that I might be able to use. So do network and such, but we do try to get students and schools involved. It often helps the school revitalize their astronomy program. Penn State, we got them on an occultation, we got the data, we got published, we got in the local newspaper, we got in the Penn State newspaper, and before you know it, donations were pouring back in. So it's a great way to revitalize colleges and non-for-profit universities. I'm also going to shamelessly give a shout out to Second Light Observatory Services. A couple of friends and I, we've created a 501(c) where we go around and help schools and nonprofits restore their telescopes and restore their observatories. We've worked with the Randolph College down in North Carolina, Belk College down there, and several others. Local Penn State, those familiar with Penn State up at State College, we just remounted their plane wave onto a beautiful, I think we put a plane wave mountain there, we fixed that, and we did some work with them. But we come up to help, we offer our expertise in getting these telescopes back up and running. So cool, so it's like, all right, this is cool, I'm interested in it. Like, how do I find out where these occultations are? Okay, this is freeware. It's called Occult Watcher, occultwatcher.net. Go to that website, download it. This is the desktop version. There's 2 versions. There's a web version, desktop version. I like the desktop version because then I can kind of like sit there for 15 minutes and scroll through it, and it's like, oh yeah, I'm home on this Tuesday, the 18th. It's at 1 in the morning. I can do that. But it tells me like where I will be within the shadow. Tells me if there's other people within the shadow. How long is the duration? Where's the moon? And it gives me kind of an idea. It's like, okay, is this something worth me trying or not? I am outside of the shadow on this one, but because it's a lucky star event, I'm going to try it anyway, because you never know. Because the lucky stars, they tend to go for those trans-Newtonians. They tend to go for the moons. So if I see one of them flag an event, I'm going to try it if I can. So this is a great tool. Again, occultwatcher.net. Take a look at it. It's just easy, simple software. Put in your site location, and you're almost up and running. The web version is also excellent, but you need to be connected to the web. The web version allows you to put your aperture in and some more variables to help you narrow down, what you want to use. If you've got specific scopes, like I got several different scopes I use, and I'll mix and match and see which one and put the different apertures in there. But on this one, it gives you kind of the GUI interface. You can see when the other people are online and who's going to be observing as well. And there I can tell the team from Westport, Connecticut, is going to be online too. So I'm going to give, Rick and Kevin a call and saying, yo, guys, you're going to be up there. So that's a tool for figuring out where those occultations are going to happen. So reading the light curves, okay? You take the data, it's your data. Your data, okay? It doesn't belong to somebody else in the cloud. You don't have to send them a letter and get it back. It's yours, okay? The only time it's not is if you're working for Southwest Research Institute or if you're working for NASA and they're paying for your trip, which they do. They paid for me to go to Australia a couple times. But my body was theirs for the whole week, and I did what they told me to do. It's a lot of long-hour days. But the fun part about it is you can process your own data. And we've got some great tools on board. This is called PyMovie, created by Bob Anderson. And here you load your data, and you can look at your light curve right here. Boom, right off the bat. You can tell if your data is good or not. Okay. And it gives you the duration of the time, and you can get into a lot of technical. We can do a whole afternoon on just trying to run this or trying to read it and such. But those tools are there. Like AAVSO's got tools for you to use for their projects. We have software, freeware tools that you can download. If you're into techno data stuff, this is a lot of fun to do. Okay, one thing about when you have your data, you got to stand by your data. I had one guy watching over my shoulder, man, and he's like, man, you got, look at all those hot pixels. Your camera's terrible. Oh my God, it's like so bad. And today, still to this day, he tells everybody that my camera's like this really crappy little camera. But no, it's not. It's a QHY174 GPS. I can push up to like 400 frames a second. Okay, we make those cameras scream sometimes because we're trying to get the data. Again, we're not trying to catch the beautiful colors and all that stuff. I'm trying to get data. And the nice part about it is when you process your own data, which is easy, PyMovie, PyOte does this, Tangra does it as well. We do our own quality control measurements. Okay, you can tell right off the bat. That's my distribution of edges due to noise, my duration of error due to noise, and right off the bat, it's like, man, that's clean data. That's some of the cleanest data you can get. So it's kind of fun because you can what could I have done better to make my data better? And so you can, and actually, if you've got your own star data, pull this stuff down, play with it. Compare your image data to this and see how much noise it's pulling up. See where you can improve it. But that's some of the fun with it. And also, when you contribute your occultation data to places like Lisa, Sweary, a couple of the other ones, senior moment there, BrainStop, you have to stand by it. And they will. You'll get the email, the text 3 weeks later saying, Rox, I think you got something bad here. What's happened? Did you have a cloud go through? Then I revisit my data and double check and see what's happening. I always keep track. If you don't keep an observation log, keep one. I just do it. I keep date, time, temperature, wind, everything on there, camera temperature, sensor temperature, and such. Because that way, if somebody has a question, I can always go back and review it. As mentioned a little earlier, I use a QHY174 GPS. QHY camera, yes, it's an older sensor. It's mono, but it's a great workhorse camera. But it has the GPS built into it. For what we do with the asteroid occultations, we need to have a GPS stamp in the FITS header. It's the way we synchronize everybody globally so we can get that nice little outline that you saw, that we're all on the same time stamps. Now, there are other tools available. One is a flash timer. You can get that. So we're seeing a lot of people now with the ZWO cameras coming out. They're putting this flash timer on the end of their scope tube, and we're actually incorporating the timing off of a known GPS timer sync. So as of today, there's a couple different ways of seeing that GPS sync. You may see things change in the next couple weeks on that. So the timing, measuring the timing is very important to us. So I suggest really just to get used to your equipment and to have fun, try to do an occultation. Get your scope on there. Get on the right field of view. Find that star. Record the occultation. See if you catch it. Run it through our software just to see your quality. Part of the challenge is just trying to get on the target star. It's really can be quite challenging. Okay. One of the lead groups that does this type of work is the International Occultation Association. Doctors David and Joan Dunham are very key people within this group, have basically created it. It is a global international team. You're not just working with 5 or 6 people. We've got probably about 1,000, 1,200 of us worldwide. And there's a mailing list. We do get published. We have our own journal we publish 3 times a year. So if you're interested in writing papers, getting your feet wet, and just basic information such, you can publish there. Our data goes all over the world. Whoever needs it at that point in time. They'll put once you're on one list, you get on another email list. Surya will send you an email, Lisa will send you an email, ERO will send you an email. Can you do these occultations for us? So it's a fun group to get into. You don't have to do every single occultation. If you don't feel like getting up at 3 in the morning, you don't get up. It's just whatever your schedule works for. All right, so with that, I'm going to leave you with a beautiful southern sky outside of Catherine, Australia. We're set up with one of the 16-inch scopes out there. It's all right. All right, well, thank you so much for being such a good group. You're very kind. Nobody booed or threw tomatoes or anything. So super. Any questions? Anything? And Brian covered a lot of this stuff, so I'm probably just a refresh. No questions. Okay, well, that's good. All right, yes?
It's just anyone can do this. I hadn't done any, I do transits, but I haven't done those occultations. And 2 years ago, there was a grazing occultation of Triton, moon.
To the moon.
Just happened to go right over my observatory.
Oh, cool.
So it's like the nice data from that one data, they were able to determine the density of Neptune's moon, Triton.
Wow.
Just all the way to the surface. Anyone can do
Yep.
it.
Yep. There you go.
Interpret the data.
Yep, they did. Sometimes, some things it's just left to the professionals. But yes, you can do this. The grazing. People do occultations of stars going through the grazing the moon, grazing stars, and which is cool because then you see on the graphs the dips of the craters and such, and those are kind of fun just for the fun of it to me to see that. SETI Astro. And it's just too new for me to put in a slide deck. I'm not overly familiar with the software at this point. Somebody mentioned it to me. SETI Astro now has one of their modules which you can do exoplanet work on it. Okay, they will help you take your images, your data, and run it through their tool to help determine an exoplanet and the dip on the light curve on it. So I won't get into too depth because I don't know if that would overlap with the AAVSO does, But again, that's just a different group, different software that you can use to just, even for fun, just, find out when these are happening, do one or two, and just for the fun of it, just, while we're watching football some afternoon, process it. Just see if you catch that light dip, see if you caught that occultation. All right, anything else? Any other questions? Well, great. Well, thank you. Well, we got one in the back. Gotcha. I believe they do. They run it through their own software. That all of that, from what I understand, is they actually do the processing, because when your images are taken, they go up to their cloud, and it kind of processes them through them and such. The Unistellar group. All right. Well, thank you, everyone. You've been a great audience. Enjoy your weekend. Enjoy your stay at Stellafane.